Okay, okay. All right, hello. Hello up there. Welcome. I am Aaron from Solace, back at you with you for another office hours. And once again, I'm joined by my good friend and colleague, Tom. Hey, Tom.
Hello. Hey, how
All
you doing?
right. This is all working. I'm doing good. How are you doing, man?
Yeah, good. Started. Did we
Right.
get started on this again? We had a good turnout last time. Hoping for another good turnout.
We did. I think the last time we did this was, about a month ago, right? Kind of mid-January, I think.
Yeah, that's right.
So yeah, broadcasting live on LinkedIn, YouTube, and Periscope. It's noon in Paris. It's 11 a.m. in London, I guess, and it's 7 p.m. where I am. So if that gives you any indication where I'm coming from, where are you joining us from? Put it up in the chat. We're happy to have you here. I'm going to be doing a little kind of looking over at this screen while I. Yeah, where are you joining us from? Put it in the chat. Say hello. Aaron, I'm in Singapore. Tom from London, and we're here to answer your questions for the next hour. So, couple Solace guys, happy to do this kind of thing. So, yeah, say hello. Hi. What's the weather like there in London, Tom? While I get started here.
Actually, it's beautifully sunny at the moment. It's really nice.
All right.
Hence the lens reflection, which I'm trying to talk about.
Oh yeah. It snowed there not too long ago, right? It's
Yeah. We come from snow to sun. So.
All right. So you should be able to see my screen at this point.
Yep.
All right. So welcome to the Solace community, your one-stop shop for all things Solace, Q&A, new exciting releases, all sorts of stuff. So let's take a browse here. We'll hopefully we'll get some questions live. You know, it's always interesting when we get people watching us and do we do live Q&A, but let's just start with some community announcements. One thing.
I just thought it might be worth saying. As one thing is we had a record month on community, record month for signups and questions and comments. So,
oh yeah,
that's really good.
That's excellent.
Activity's increasing. Yeah, it's what we like to see.
I certainly didn't pull my weight. I don't think I was a little quiet during January on the community. So I'm looking to actually improve on that this month. So one thing, did we talk about this last time? I can't remember. The Python API is now GA. I think that hasn't happened. This is more new. So for all of you Python devs out there, people that use Solace with their I don't know, scientific platforms to do like analysis, like Python obviously is a great API for doing all sorts of things. We have a 1.0 version. It's been EA for several months, and now it's actually released. So very, very cool. You can find out how to download it on the community here. And also, because it's official now, you'll find it on our downloads page and in our documentation. So yeah, if you're keen to try out Python, go check that out.
Give it a go. We've actually had a couple of EA customers in the European region, so we've had good take up so far.
Very cool. Hopefully people like what they see. Obviously, you know, we'd rather try to get it out the door sooner, into people's hands sooner. So it's not fully featured yet. There are going to be things that don't quite work yet. So, you know, request reply in terms of a message exchange pattern is not there yet. That will be in the 1.1 release, which will hopefully be fairly soon. But all of your basic kind of publish, subscribe, you know, persistent messaging, that is all in this particular release. So check it out. If you have questions, if you have comments, bug fixes, hopefully not, come and find us on the community and let us know.
Yeah, it's interesting to think about Python API. It's a slightly different model behind it. It's got this kind of service model. So you ask for a publisher service and things like that. So it's slightly different, probably a little bit more modern than our other APIs, I'd say. That's
right. So in the last about year or so, Solace has been undertaking a plan to revamp and modernize all of our APIs. You know, one of the ones that's been in the works for quite a while is our Java API. And you're right, they're taking a very kind of different approach to it. It's a rethink of how the API is kind of constructed internally, and some of the concepts around messaging and brokers and what a subscriber is and what a subscription is. So it's a little bit different than our traditional, our I don't want to say legacy, but our current set of brokers, or APIs. Sorry. So yeah, it's going to be a bit of a learning curve, even for us Solace people. to use new Java API or Python API thing. Some things are not quite the same as they have been for some time. Hey, Tom, here's one for you. I don't know if you know this. As part of my trying to contribute to the community and make sure I post
I thought you might pick up your latest post. Yeah, go on.
Yeah, why not? A little bit of self-promotion. I did this afternoon. So in Solace, this is something that we trained people about. We always bring it up in our workshops. Is the concept of wildcards, how you can use wildcards on the subscription to route data that match a number of topics. And we have the two different types, the star and the greater than. And in MQTT, because Solace is a multi-protocol broker, we support MQTT wildcards as well, which are the plus and the hash, and they're similar but not quite the same. So for example, in MQTT, the plus is a single level wildcard, but the spec you cannot use it with a prefix like you can with the star in Solace, right? So like for example, I have this hello/WO star, and that will match that hello world, but as well as hello woman, for example. MQTT doesn't have that. That said, Solace does actually allow it. You can actually, if you have an API that allows you to put the plus in there, Solace the broker will actually work. And then the hash is the multi-level, but it's a 0 or more rather than a 1 or more, right? So going back years, we've had customers saying, hey, is there some way to do a wildcard that will give me what did I write it here? Yeah, so hello hash will match hello, it'll match hello world, and it will match hello world from Aaron. Can you read that all right? Let me zoom in a bit more here.
Yeah, perhaps a bit of zoom, but it's okay.
Let's keep going. Look at that. There we go. That's pretty zoomed in. So there is actually a way to do this in Solace, and I bet you most people don't know this. I bet you most Solace people don't know this. So there is a special way, a special character that you can do that will actually give you this functionality. It's because it's an unprintable Unicode character. It makes it a little difficult when you're showing it on the CLI. You can't actually see it, but this is how you do it. So this will allow you to have the functionality of the MQTT hash, which is 0 or more, but using SMF, using our Solace topics. So pretty wacky stuff. How about that?
I love that. How the hell did you find that out?
I just went digging through documentation. I was reading about MQTT. I actually found it out because I was doing a subscription manager. So my bus demo, right? It basically applies subscriptions to WebSocket clients so that the WebSocket client doesn't actually have to know how to subscribe to something. It was for the next generation of the bus demo, which is the taxi demo. So we've gone from buses to taxis now. And this taxi demo is public. We provide the stream. We have credentials that people can go and listen to the taxi feed themselves. And as part of that, I was like, I want to implement an MQTT subscription manager, and I needed to be able to do this particular wildcard. So this is how it's done in Solace. So if you're a Solace user out there and you've always wanted to know how to do something that will match not only hello, but hello world, as well as hello, blah, 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 with one subscription rather than having to use two, then this is the way to do it. So a bit unusual. But
very cool, very hacky. Yeah, we could talk about best practices though. Topic best practices. I think it's safe to say that you should only do that with a good reason for a short amount of time because it's confusing as hell.
It is a bit confusing. So it certainly saves you 2 subscriptions. You don't have to subscribe to both hello and hello greater than. So that kind of helps. But yeah, it's a pretty unusual scenario where you need to when you want to do this.
Yeah, it's kind of regex.
Again, for me, it was
kind of regex, isn't it? It's kind of that. Yeah.
A little bit. It's basically saying you don't have to have that last, you don't have to have the last level coming afterwards. So anyway, we got some comments here. I'm gonna see who's out there. Let's see who's out there again.
Hey,
Jack.
Yeah, one of our favorites, Community Spotlight Member of the Month there.
That's right. Let's bring that up. Why not? Let's make him embarrassed out there. So Jack
is right for asking a question.
That's right. Where is it? Here we are, our developer spotlight. If you want to know all about our friend Jack here, come and check it out. He is happy to talk about what he does in Solace and what he works on in his job. I like the fact that you started on Commodores, man. That's pretty awesome. That's a tiny bit before my time. IBM PC XT was my first computer, so that's kind of when I started to play around.
You could tell I'm from the UK because mine was a ZX Spectrum, a Sinclair ZX Spectrum.
Sinclair ZX Spectrum, very cool.
Yeah, all 4 bits of sound or whatever it was.
So, welcome, Jack. How's it going? All right. Who else is out here? Hey, Manish. How's it going? Good to see you. You're joining from Poland. Oh, you're in Poland. I didn't know that. So, my middle name is actually Wojciech.
Is it?
Yeah, it is. Yeah, my mom is Polish American, and my dad's Canadian. My mom's American. My mom, her last name was Wojciech, and so when I was born, she put that as my middle name. So yeah, my middle name is Wojciech. So I got some Polish. I can't speak any Polish, but I have Polish genetics apparently. So yeah. Anyway, how you doing? How you doing, Manish? Good to. It's nice and sunny. It's a sunny day. Excellent. It's a sunny day in Europe. That is good. We actually had rain for the first time in Singapore in about a week. It's been unusually dry. Yeah, kind of wacky.
Okay,
hey, Krishna, how's it going?
Yeah, we got some questions.
Yeah,
we've got Krishna's got some questions and Jack's got some questions. Yeah, okay. Summarize the strengths of Solace versus Kafka. That's a question I've never heard before.
Never.
Yeah.
No.
It's quite it's a very common question, that one. So where to start? Okay, so we have some interesting pages on that, but I think from my point of view, from my experiences, you can sum it up with a few things. And it really comes down to complexity. 2 angles to that: developer complexity and operational complexity. Operating Kafka, I don't think I'm spoiling anybody's party here by saying operationally Kafka's not particularly simple to operate, right? There's moving pieces, there's a lot of parameters to tweak to get exactly the behavior you want. So there's different effects. If you really want guaranteed messaging, there's a whole load of tweaks you have to do, which kills performance. What if you want to do encryption? If you need to encrypt the data in flight, that tends to kill performance too. And then you get into the whole sequence of, okay, well, when you're planning out your deployment in Kafka, it all makes sense, right? You can plan the number of partitions and start creating your kind of topics. But things start to break down a bit once you start to mature your architecture and you start to bring new services on board and off-board services and start scaling out services. So what happens if you've got the number of partitions? You need to scale out your consumer load balancing a bit more. Well, then you get into the whole piece of what about partition rebalancing, all this kind of thing. It's interesting, actually, if you read, there's a LinkedIn engineering blog where they talk about all the tools they've built alongside Kafka to deal with some of these things. He says, segueing neatly into something where he's forgotten the name of the tool. It was something like Boston or something like that, that was intended to go through and bring it periodically, do this rebalancing piece, which is not easy at all.
Yeah, I was going to say I've heard that developers love it. It's easy to get started. It's a little Java app that you run like locally, but yeah, operationally it is quite complex. And then LinkedIn has put a lot of effort into making sure that it runs well. But specifically to Jack's question here, it's often used. It's not suitable for EDA. It's more designed for high volume logs, long-term storage. What do you think?
Yeah, I was just about to say, one of the things we often talk about is data at rest versus data in motion. And Kafka's great for your data at rest. You've got this immutable log where you can just go and kind of read it, but it's not so good at those kind of real-time streaming EDA cases. I was going to segue into hierarchical topics, Aaron, but it sounded like you were getting started with something there. So.
Well, Kafka was built, so a lot of the terminology that you hear in the Solace world and the Kafka world overlap. There's topics, there's publish, subscribe, but how they've been implemented are very, very, very different. I always tend to think that Kafka has implemented PubSub from a database kind of perspective, right? Because a topic in a Kafka world is a log file, and you're just appending to this log file and you're reading from this log file. So yeah, so for event sourcing, Kafka is great. for kind of one directional streaming of data, it's good. It's what it's what it was built for. It's a log shipper. But when you start looking at kind of a many to many or any to any bidirectional type of use case, which you often get with microservices, they need to communicate in random patterns, and it's more of a mesh. Solace has implemented PubSub in the network. So we are essentially TCP++. That's what you can really think of as Solace. Is like when you think of your network, think of Solace, because we can do unitcast, we can do broadcast, we can do fire and forget, we can do persistent delivery, we can do replay, and you really should treat Solace more as your network connection, whereas Kafka is more of your database. It can feed your analytics. It's good to store things, event sourcing, but if you have it's for kind of like a lightweight microservice architecture, event-driven, yeah, it's not the greatest fit. And we've heard a lot of customers say it's kind of almost too heavyweight for that type of communication pattern, right? So,
so let me
yeah.
So we give you a couple more examples of that. So on the bidirectional piece, let's take an example of somebody like Daimler, where not only do they want to get information from 10 million connected cars, but they need to ship information back to individual cars.
Yeah.
So how are you going to do that?
You can't use Kafka. Yeah.
Yeah, you can. You can create 10 million topics. What's the problem?
No,
one for each car dynamically.
Hive or Rabbit or something like that.
Yeah, exactly.
Another broker.
Yeah, exactly. Right. That kind of stuff is really difficult. And you talk about developers like it. Sometimes I wonder why, though, because some of the things you can do with a queuing-based system, and this is not only Solace, but just general message queuing, are things like poison message handling. So what happens if your message constantly kills your consumer, right? In Solace, we can say, oh, do you know what? I've tried 3 times. Let's drop that off to a dead message queue. You could do things like publisher restart. You can understand what was the last successfully published message really easily using a last value queue.
Yeah,
little things like that have just built up over the years. Just make it easier.
There's a lot of really good features that are in Solace that Solace is a very mature product. I mean, it's been deployed in enterprises for like a long time, longer than Kafka for sure. So there's a lot of features and functionality and capabilities in Solace that Kafka just does not have. Anyway, we could go on to move on. Yeah. but I was just going to say, if you want a Solace slanted view of the differences, this webpage I'm on, this is solace.com/Kafka. It is a kind of a one-stop shop where we put kind of all this information. But hey, come to the community. We're happy to chat about it some more. We can talk about this for days, right?
2 more points before we finish on this: event mesh, hybrid multi-cloud, and multi-protocol.
Yes,
that's all I'm going to say.
Yep. Those are all good. Multi-language, multi-protocol support, event mesh, and hybrid multi-cloud. Yep, those are all. I guess those are summarized in this little. I've never actually looked at this page, but anyway, solace.com/Kafka should have most of this information, hopefully. So, yeah. All right. Thanks for the question, Jack. Let's move on.
Yep.
Oh,
so
he likes your ZX Spectrum there.
Yeah, so. Spectrum people. Okay. Should we do Krishna's?
Yeah, let's go next here. All right. We are having 2 Q endpoints subscribed with the same topic name as a subscription. All right.
Good.
Producers publishing the same number to the topic name, the same number of messages on both queues.
Yes.
Yep. Good. That's so far so good. Correct. That's how for those that don't know or are newish to Solace, that is how you implement the publish subscribe pattern with persistence in Solace. We always suggest publishing on topics. If you want to use persistent messaging, make sure your delivery mode is set to persistent. But then on the consumer side, if you want to, do publish subscribe, you can subscribe directly to the topic. That is for direct messaging. But if you want to use persistence, then you configure a queue. You have a queue per consumer or per consumer group, and each one of those queues is subscribed to this topic or topics that you want to have in the publish subscribe. So very good. That is how you set that up. And next question then. We don't see the same number of messages, both messages on the queues. Oh, all right, that's interesting.
Interesting. Okay.
So, Tom, how would you go about doing that?
Stage 1, check your bind counts. Is there somebody consuming from your queue that you've forgotten about? So, Aaron, I don't know if you can bring up PubSub Plus Manager and we can see.
I'm going to log into my cloud. Oh, it's just what I was thinking there, Tom.
Ah, look at this. It's marvelous.
Let's log into
hopefully everybody's
cloud.
Yeah, hopefully everybody's familiar with the Cloud Console and how you might go and find one of your services. And then we'll bring up our PubSub Plus Manager.
Actually,
and you can see how you can debug some of these things.
So even if you're not using Solace Cloud, this PubSub Plus Manager will be the same if you're running the Docker container locally, or the OVA or whatever. So
it's dead easy to use. Just open your browser. If you're running Docker locally, for instance, you just type in localhost :8080, and away you go. A whiz-bang PubSub Plus Broker Manager. Excellent. So here's our queue, imaginatively named Q1. Yeah. So, yeah. So if we go consumers here, we can see who's connected to the queue.
Nobody.
Now, if we want to make sure that both queues have the same number of messages, we probably want to make sure we don't have any consumers on the queues, right? Because what might happen is that one consumer consumes messages or something, and it'll change the number of messages in each queue. That's right. So that's stage number 1, is check that nobody's consuming from your queues.
Just okay. So let's add a subscription to these queues, right? So
yeah.
How about hello greater than, my classic hello world topic?
I think you should do hello Unicode character 03.
I don't know how to do that in the web GUI because it's Java code. I can try. I don't think it's going to work.
Just don't.
It's probably going to subscribe to that directly.
It's going to use that as a literal, maybe.
Yeah, exactly. Yeah, well, yeah. Silly. Don't listen to me. Just use regular Solace topic. Okay, so then we have 2 queues. They're each subscribed to hello greater than. So,
so let's, can we publish the messages?
Yeah, let's use the TryMe tab here. Good old TryMe. I'm going to have to set some username and passwords. So this is Solace Cloud Client. And I'm going to have to stop sharing my screen for 1 second.
So while you're doing that, Aaron, Manish and Valdemar, we see your questions there. While you're doing that, Aaron, I might pick up Manish's question on the difference between request reply and synchronous. Yeah, Manish. So request reply looks very much like a synchronous REST call, right? I'm going to send in a request and I'm waiting for an answer back. The thing to think about there really is it blocking? So do I block a thread while I'm waiting for an answer to come back, right? You can do that in Solace if you want. There's a blocking, normally request call, and then basically that will sit there and wait for the request to come back or timeout. You can do it asynchronously though. So you send off the request and you do some other stuff, and then you're waiting for the asynchronous response to come back. Now, obviously, you need to be able to say, okay, well, you need to be able to assign which request this response came back from, and that's where we use this idea of correlation IDs, right? So we say, okay, this is request number 57, or I've got a response for request number 56, so I can line those up in my code. So what's the difference between request reply and synchronous? Well, if you make the request reply pattern blocking, then it's a synchronous call, but you can do request reply asynchronously if you wish. And that's really a bit of optimization around how many outstanding requests you can have in your code in a single thread, that kind of thing. As ever with Solace, right, we recommend you use asynchronous if you can, simply because the performance is better.
I would say it depends on the situation, right? I think
we always have this argument, don't we?
A blocking request call is sometimes just easier and useful, right? Because your thread kind of stays there, and you get the response back. Like most of our APIs have the convenience feature of the request object. But yeah, it's exactly what Tom was saying. I mean, so request reply, you can implement it as asynchronous, and then you just have to do some which correlation, which response was this for, because you could have 20 or 30 outstanding requests, and as the responses come back, you're like, oh, which one is this responding to? When you use the convenience function, it adds that correlation ID for you. But yeah, under the covers, it's doing asynchronous, non-blocking request array. It's just the API is making it look like it's blocking. So yeah, there are performance benefits to doing asynchronous and non-blocking calls that you don't have to kind of like park your thread. But for kind of lower performance applications, I don't know. It doesn't matter.
Yeah, I mean, you save with using Blocker, you do save a boatload of code. There's no doubt about it. It's a lot more easy to understand what's going on, especially with error handling as well, actually. Because
yeah, with asynchronous, you hit send on your message, and then your thread that you published on kind of can sleep or go into a loop or whatever. And then at some point, you get the response back on your callback, which is on a different thread, and that now has to go and figure out, okay, who is this responsible for? So you have to have some shared data structure where you're keeping the track of the correlation IDs. So, to implement it yourself, it's a little bit extra work, but your performance will be better in the long run than having a bunch of threads that are all blocking and sleeping, waiting for responses to come back. So, by the way, Tom, your microphone is making a lot of noise on your shirt there or something. So, it's a little bit annoying. Oh no! Oh, it's all twisted. Maybe that's why. Okay, let's go back to Krishna here. Oh, welcome back, Tom. Welcome back. Let's oh, he's still going. All right, so we've got I have my two queues connected here, and I'm using the TryMe tab as a test publisher. Obviously, if you have your own publisher publishing, that's great. Now, let's publish some messages here. So publish one message, publish another message, right? Publishing a bunch of messages. Let's publish. So there we go. I've got 20 messages published. What do we expect to see on the queues if I go back?
Well, hopefully, since they're both subscribed to the same topic, we should see the same. Is my microphone better, by the way?
It sounds great. Yes, I think it was just rubbing on your hoodie. So yeah, exactly. We're publishing on the topic. Because of the subscription, the queues have the topic subscription. Each queue should have identical, exactly the same, in the same order, messages from each other. So if you don't have the same number, that's what Tom was kind of trying to say, is like make sure that you don't have a consumer already connected, that is maybe listening to those. Because if I go ahead and start subscribing, let's go back to my TryMe tab here, and my subscriber, I want to do a bind. So let's use the guaranteed messaging version. He will subscribe to Q1. And of course, as soon as I connect this guy, he starts receiving messages from that queue. There's all these 20 messages. If I go back now and take a look at my queues, I'm like, oh, doesn't have any messages because it's been drained out, right? You might have a publisher that's silently consuming them. So here's my consumer. This is what Tom was saying, is you can see the bind count here. So yeah, if they have the same topic subscription, they should have the exact same number of messages.
Okay, so some other reasons then why we might see different number of messages. Actually, that's a good point, Aaron. Yeah, the stats screen is a good place to start looking to get some hints. Yep.
Yep. So you can see stats here, how many messages have gone through this queue. You can clear this to reset it back to kind of 0 and then start your testing again. So that's poking around the stats, you can take a look at some of the information that's there as well. So yeah, there we go. Message priorities. Oh yeah, message priorities. That's fairly new. Anyway, check that. That's kind of where I would say to start. So do you have any other
things? Yeah, some other things to look for. So Aaron, could we go back to the main queue view? Supposing the queue was shut down for some kind of period.
Yeah.
Right. So maybe what we've done is we've turned off one of the queues for a short time.
Not that one. This one, right?
Yep. So if we shut down incoming, then what happens when we publish messages, obviously, is they won't land on that queue. So if you just,
But they're also not landing on the Q1 because I still have my consumer stock.
Well, they are. Right? They are landing on it. They're just being consumed.
They're going through it. So let's turn off that guy. Publish a few more messages here. Publish, publish, publish. Now in my queue, he's still at 20, and this guy has 17 new messages now.
Okay, so there's something else we should look for too. If we go into the details for a queue, and what we're looking for is the high watermark.
All right. Should be in the stats.
Is it in the stats? High watermark, right. So we need to line that up against the statistic below, which is the queued quota, right? What happens if one of our queues is filled up because, say, one of our consumers is slow? So a consumer on Q1 is keeping up with the messages fine, but the consumer on Q2 is slow and the queue's filled up. Well, what happens then? Right?
Yeah, by default, our queues are sized at 1.5 gig, but you can make them any size you want. Yeah, if the queue hits its threshold, then yeah, you're going to get. But the publisher should get an error, right? The publisher should get something that says, "Hey, one of the queues is full." So your publisher should see something if that particular thing happens.
Yeah. Yep. Unless, of course, there is an option on the queue to say, "Do you know what? If I'm full, I'm not going to notify the publisher."
That is a special queue setting.
Yeah.
If I go into the advanced settings here, scroll down a bit, yeah, you can essentially tell your queue to be best effort. Best effort guaranteed. So reject messages to sender on discard. So if your queue discards because it's full, by default, when queue is enabled is the default. Oh, let me scroll back down. But you can also say always, so even when it's shut down, or never, which means if the queue is full or there's an error, the publisher doesn't get a negative acknowledgement. Reject messages to sender on discard. It's a little bit of a strange phrasing, isn't it? I've kind of gotten used to it over the years, but it essentially says, do you want to tell your publisher when there's a problem? That's essentially what it means, right?
Yep. So typically when people are feeding analytics engines, where actually it's more about the temporal aspect of persistence rather than the never lose a message aspect, that's often when you might turn that on to turn that setting on to never, right? Because you don't want your analytics pipeline to stop your entire message flow.
Yeah, that's a really, really good point there, Tom, is sometimes, some applications are critical to never lose a message. So if your queue is full because of some problem, you want to stop your publishers to make sure you're not losing data. But in some cases, you kind of want best effort, right? So I would prefer not to lose any data, but if the queue is filled up, something's broken, I don't want to stop my publishers from being able to keep going. So certain kind of sidecar kind of analytics is a great use case for that. It's like things that are not mission critical. Maybe you want to be configured to be never rather than enabled.
Cool. So Krishna, hopefully you've got some ideas there. So check you haven't got any consumers connected. Check there's been no enabling, disabling the queue. Check the queue has
stats.
Yeah, check the stats. Have a look, see if there's any unexpected errors, that kind of thing. Check you haven't, the queue hasn't filled up at any point. You can look at the event logs, for instance, to see if there's been any, your queue quota's high, that kind of thing, events. It's a good places to start. So have a look. If you don't find an answer there, then please go on to Solace.community and ask the question, and we'll jump on it and try and help you figure it out.
That's right. Yep. Great. Thanks for the question. Let's move on here.
Yeah.
All right. So Manish, we did that one already. Okay. Yep. That's a good standard question. Yeah. Hi there. What are the main differences between direct messaging and persistent messaging applications? Between the applications or between the quality of service as to how Solace treats these messages? That's almost two different kind of questions there, right?
Yeah, so if we talk about applications, we could maybe talk about what kind of data applications we're talking about.
Sure.
So direct messaging, right, what's the key point there? The key point is that with direct messaging, if your subscriber is not connected to the broker, those messages are gone. It's not going to get them. That's probably the, of all the simple things to remember about that as an application, that's the key thing to remember. You've got no kind of temporal, time-based saving of messages, if you like. So What then would you use that kind of thing for? Well, obviously, if you've got data that's kind of being produced very often, that has an age to it, then you probably want to use direct messaging.
Or like it's low value, right? Like a temperature sensor every second or something. Or something that's...
So kind of three broad kind of areas there. What about kind of just plain application stuff? Well, what about application heartbeats? Right, an application heartbeat is only relevant for a second, 10 seconds to let you know that the application is still live. It doesn't matter if you get a heartbeat from yesterday; you don't care about that. So that's a good example of a direct messaging use case. Right, I'm going to send out a heartbeat. My applications, unless it's some analytics application that wants to know how, like a Splunk dashboard or something, unless it's something like that. Your other applications who are going, oh, is my other application live? I need to check that and send an alert if it isn't. You don't want persistent messaging for that. It's going to hold you up.
For all of my demos that I do, my bus demo, my Dragon Boat race demo, they're all direct messaging because I don't care about stuff that happened a week ago, right? I'm not looking to keep every message, so that's all direct messaging, which you could almost think is like analogous to just like a TCP call, right? A TCP socket packet.
Yep. So Aaron mentioned the idea of IoT kind of use cases there. If I'm updating a location or something like that, that's on a moving vehicle. Again, that's probably time sensitive. I don't care where I was 2 days ago. Maybe I don't even care where I was 30 minutes ago. I only care about my current location. And the last one, the classic one for this is getting market data from like your stock exchange, right? I don't care what the price of GameStop is 10 minutes ago. I care what the price is now, right? Especially if I'm on Wall Street Bets, right? That's another key thing, right? I'm not really interested in the old price. I don't really want to wade through a load of old prices before I get to the current price. All I want is the current price. That's the only piece of information that's of interest to me.
Yeah. And typically there's a performance benefit to using direct versus persistent simply because we don't have to store the data in a disk or some non-volatile storage, right? So if you are in that particular use case where microseconds count, latency is super important, direct messaging is going to give you a performance bump as well. So as long as it's timely information and you want it as timely as possible, then direct messaging is the fastest and lowest latency that you can get with Solace. And
it's easier to code because it's fire and forget. I send a message, I'm done, walk away.
Yeah.
Right. Whereas if I'm persistent, has the broker got it yet? I have to wait for my NAC. Ooh, I've got a NAC. What do I do now?
Yeah. As long as you have a network connection to the broker, you're 99.9 times out of 10, your message is gonna make it to the consumers. It's the only times you don't is, if you've disconnected, like your TCP connection is gone, the APIs will automatically reconnect, but while you're offline, that data is lost. And then, in the rare case, you have a buffer overrun. If your consumer is so slow that it cannot keep up or with the full rate, then you can lose some messages in that regard. But direct messaging is actually it's pretty good. It uses TCP, so there's a lot of inherent network reliability there. So direct messaging is actually, as long as you're online, you're going to get that data. Pretty much, that's it. So let's talk about persistence now.
Okay, persistence. As you can see there, I see down Aaron. You're going to store the message to disk, right? At the end of the day, you're going to put the data into a persistent store. Now with Solace, we don't use any kind of external software for that, right? It's all done internally to the broker. It's all managed by the broker. But what that means is if you're offline, we're still going to store that message, even if you don't want that message. That's the meaning of persistence, right? So when you come back online, we're going to keep everything in order for you. It's a message queue. And we're going to send you that data, as you probably saw in the earlier TryMe examples. We're going to send you all of those messages in the order that they arrived. From the application. So that's obviously for anything where you can't afford to lose the data. So in your IoT example, that could be commands going back to the device, as an example. If you're making
something important, anything really important, right?
Payments is a good one. right? I don't really want my salary payment to disappear into the ether if my bank's bank systems go down for 10 seconds, for instance. I would get very upset at that.
You're buying a billion Bitcoins or something. You don't want to lose that data. So that needs to be protected.
I don't know, you might do. Depends if you're Elon Musk or not, I suppose.
Yeah, so persistent messaging, it's when you can't afford to lose the data, but also when you don't have a way to recover the data that could have been lost. So going back to direct messaging, in a lot of cases, your publishing application is not just creating messages or data out of thin air. It's often reading it from a source. This could be another application. It could be a database that it's publishing from. And in that case, if there's a problem, it might actually be able to go back and say, oh, I need to refresh myself or go back to, I can republish things that I lost. But with guaranteed messaging, once you've sent that message, the publisher sent that message and the broker sends that acknowledgement, we talk about ACKs and NACKs, negative acknowledgements. Once the publisher gets that ACK, Solace guarantees that data will not get lost. It will not lose it, no matter what, no matter if there's power outages or network outages or whatever. So this is the case where, the publisher can now wipe their hands clean and, just trust that it will get there, right? Just like the post office, a super guaranteed post office. That's what it is.
Yeah, I mean, there's an important point there around state. People, especially in kind of the microservices area, talk a lot about state and who's got responsible for state, and we're building a distributed system. We don't want all our distributed components to have state. We want them to be as stateless as possible. And this is kind of an excellent way of doing that. You have a central component with state. I mean, this is kind of behind the event sourcing model, right? You have a central component with state, and that is your event broker.
So thanks for the question there, Vladimir.
Can I make one more? Can I make one last point, Aaron? So from the application point of view, direct messaging, fire and forget, press send, job done. For persistent messaging, at each end, publisher and subscriber, it is not fire and forget. You must wait for your acknowledgements before you say, I'm done with the message. Because as Aaron was alluding to, there's a responsibility handover, right? I'm handing over state from the publisher to the broker. So the broker must tell me when the broker is happy that it has got the state. And it's the same on the subscriber end, but obviously reverse. The broker is handing over kind of state to you. So you have to tell the broker that you're happy that you got the state. Quick developer tip here. Please don't do that until you've done whatever you need to do with the data, because what you don't want to happen is your application to crash and you to lose that state. So let's imagine you're updating, say, a database table, right? Wait for your database to tell you that the table's been updated before you acknowledge the message back to the broker.
Yep, cool. I just brought up my whiteboard because I thought maybe I could draw a picture, but I think this is pretty. I was going to just draw a queue and some acknowledgements here, but I think that's hopefully pretty clear. I have a video on YouTube that talks about publisher acknowledgements and negative acknowledgements, and it's kind of like how to make sure that you watch for those and some of the error conditions that you can get. Yeah, with persistent messaging, you have to make sure you're waiting for those ACKs and NACKs to come back. Or to give them as a receiver, you need to give that ACK when you're done with that message. So thanks for the question. Great. And again, come chat us on the Solace community, solace.community. If you want to just continue the discussion, we're happy to talk about it more there. All right.
Okay.
Jack, how to implement async request response with Boomi? Ooh.
Oof, this one's for you, Aaron.
I haven't played with Boomi yet. That's not one for me. I'm wondering if we definitely have a lot of customers and a lot of users out there who are using Solace and Boomi. It's a great mashup of technologies, actually. The kind of the iPaaS, the integration, the reach and the connectivity that Boomi provides Solace, and Solace does the whole eventing enabling. It's a really cool combination, but I don't know the answer to this. So do you, Tom?
I don't, I must admit. Obviously, there's the V2 connector is new. I imagine there might be something we do there. We should check, I think. So, Jack, do you know what? Can you put that question on the community? And then that way we can stick an answer up, right?
Let's see if he already has. I'll give this a refresh. But yeah, any questions that we don't know? Like Tom and I know quite a bit, but not everything. So you know, put your questions up here. It'll make sure that, you know, some of the more knowledgeable Solace people out there will be able to kind of pitch in and maybe get you an answer. So thanks for the question, Jack. I would be interested to know as well. Thanks, thanks for that. All right, Raphael, hello. For Event Mesh, do you guys see some kind of service mesh implementation like Istio under the hoods? Oh, do we use some kind of service mesh implementation? Right. Tom, you're the special guest. Do you want to talk first, or do you want me to kind of launch into that?
I've got a bit of an essay to say here, and that is no. No. So yeah, Solace, we tend to like doing everything in the broker. Like, we don't have separate components to do message persistence. We don't have separate brokers to do things like leader election or anything like that. So we see event meshes and service meshes as being complementary. Mm-hmm. Right, so your event mesh is obviously for events. It's for asynchronous event distribution, whereas your service mesh is more kind of synchronous. And you've got a lot of the similar kind of characteristics there. So you've got kind of a degree of service discovery in the event world, and that's through our kind of event mesh capability. And it's a technology under the hood is called DMR, Dynamic Message Routing. And basically what that enables us to do is to understand where the events need to be routed in much the same way that a service mesh understands where a particular request needs to be routed.
I always think that, like, you know, I didn't know much about service meshes before maybe about a year ago. And I kind of thought, you know, when I heard about it, it's like, okay, they're implementing more kind of message exchange patterns in the RESTful world, because a lot of REST microservices, you know, you typically, it's point to point. I'm talking to a particular endpoint, a URL, and the service mesh essentially kind of abstracts that away. So the app, the microservice, doesn't really need to know where that data is going, and the service mesh can route that to other, you know, microservices. It can duplicate that data. It can load balance it. It can do whatever, and it kind of just removes that from the application's you know, needing to know about that, right? And I think that Solace, you know, at a routing level, provides a lot of that functionality anyway. So, you know, from an eventing sense, right? So, you know, we do have a separation of a control plane and a data plane as well. You know, you can the routing of the information through Solace can be controlled from the admin. And it's just it's complementary to what Tom was saying. Yeah, it's just more asynchronous, using bidirectional publish subscribe type protocols than, you know, more RESTful or gRPC sometimes as examples in your service mesh. So yep, Solace does not use a service mesh. We do have some customers that are doing cool mashups where they're kind of bridging from the Istio world into Solace and vice versa. It's all kind of POC-y at this point, from what I understand. But there is some cool things you can do there. But yeah, they are complementary in how you build your microservices, whether you want to use REST and or Solace, and how they kind of you fit them together. So this is a blog. I just Googled service mesh versus event mesh, and this is a blog from our CTO. He wrote it a year ago, half a year ago, 6 months ago. And I think it actually goes through and explains kind of some of the differences and why you might want to have both. Here's our complementary picture. You've seen this before, eh, Tom? Mm-hmm. Where you have both, a little bit of both. So yeah, check that out. Hopefully that answers some of your questions. They are complementary, but Solace does not use a service mesh underneath the hood, even though we have the name mesh in our event mesh. Thanks for the question there, Raphael. All right. Hey, Manish. Hey, Tom. It might be silly questions, but why are there two TryMes in the console? What's the difference? Ooh.
Let's go. Let's have a look.
Let's go have a look.
You've expired, Aaron.
That's weird. I just logged in like just 10 minutes ago, didn't I?
Well, it's been a while, actually.
Now everybody's going to know my email address.
Oh, no.
So that's a very good question. There's actually 3 if you knew where to look for the software getting started. But yeah, Manish. So people that know Solace Cloud,
Do you want
when
to
you log
zoom
into
in a
Solace,
bit, Aaron?
oh yeah, sorry. When you log into Solace Cloud, you have your dashboard here. You can have all your Connect information, monitoring if you want, and the TryMe. So the Solace Cloud TryMe that has the publisher and subscriber. And so here's your little WebSocket app. This is my subscriber, this is my publisher. They can both talk through the broker. But then if you go into the PubSub Plus manager, when you first log in, and if you're using Docker or the OVA or whatever, this is your, you don't have the Solace Cloud. This is your kind of first thing that you see when going to the broker. Click on TryMe. Also, there is a publisher and a subscriber. So what's the difference? The Solace Cloud TryMe, the publisher and subscriber, came out first. It was rolled out in Solace Cloud because it's a SaaS. The R&D team there can make much more rapid prototyping than doing big changes into the broker. And it was definitely an inspiration to add the TryMe into the actual broker's admin. So it certainly makes doing little publish, subscribe kind of ping pong tests a lot easier. Tom and I, when we joined, there was no fancy GUIs. We had to use a command line tool called SDK-perf, which is available to download on our downloads page. It's a great tool for doing load testing. We use it to do hardcore latency testing and all sorts of stuff. It's a really powerful tool available for all of our different APIs. So check out SDK-perf if you need to do something a little bit more, 10,000 messages a second, no problem, versus the TryMe tab here. Yeah, Tom, do you have something to say?
Nope, that's about it. I mean, I still use SDK-perf most of the time.
I use, depending on the which environment I'm in, it depends on the TryMe tab. So when I'm using Solace Cloud, I actually tend to use the Cloud Console version because it properly populates the username and password and all that information, right? So, but when I'm running the Docker container locally and it's all localhost, these are all just default, right? Everything's just default. It's actually a lot easier to use this. One difference you might have noticed, the one inside the manager has persistent messaging capabilities, right? I can say down here that I want to use persistent messaging. You can publish directly to a queue if you want. On the consume side, you can either subscribe to a topic for direct messaging. That should be capital D in my opinion. Or you can connect, bind to a queue, so directly to a queue. So you can use both persistent and direct. With the Solace Cloud version, it's only direct messaging. It's only just topics. So this is actually a more fully featured TryMe capability. And eventually, I think the Solace Cloud one is going to go away. So yeah, so that answers that. Unless we misunderstood and you're wondering why there's 2 different panels here, one's for subscribing and one's for publishing, but I don't think Manish was asking that. So cool. To call an outbound call from Solace using REST endpoint, what happens if the downstream system is down?
Ooh,
okay.
Good question.
Tom, take it away.
Okay, so actually this is quite a good place to talk about the difference between REST messaging and probably the microgateway mode. So outbound call from Solace using a REST endpoint. Okay, so if we think in the messaging world, we're going to be so let's just back up for people who may be not quite sure how Solace REST messaging works.
I'm going to try and draw on the whiteboard while you're talking there, Tom. So
yeah. Okay. So let's see if we can coordinate speaking with somebody else drawing on the whiteboard. That should be interesting. Okay. So in the Solace world, you have this idea of being able to call out a REST message. Well, the thing is, though, it's an outgoing call. Right? I'm going to call a REST service with the contents of my message. So how do we do that? Well, we need to set up a special kind of service object to do that, and that's called a REST delivery point, and that's where we can specify things like, well, okay, which queue do we want to read from? So that's a queue binding. So we say in my REST delivery point, I'm going to bind to this queue, and we're going to read messages from there. Then we need to say, okay, well, what am I going to deliver to? And that's called a REST consumer. And the queue binding and the REST consumers are all inside something called an RDP, a REST delivery point. And a REST delivery point is just an object on the broker that kind of encapsulates all this to make it easy to understand what's going on. So,
by the way, can you see my thing? Because
yes.
I can't actually see you. Okay.
Nope, it's all good. Okay, so when we're configuring our RDP, we configure the REST consumers, which are things like, okay, what service do I have to call? Now, in the messaging world, there's kind of an assumption that you've always got a connection there, right? But it's not quite that easy in the REST world. So what happens if my REST endpoint is down? Well, this is, if we're in the messaging world, there's an assumption there of retrying. So what will happen is our REST consumer object will detect that your downstream system is down because the TCP connection, the underlying TCP connection underneath HTTP will disappear. And then what will happen is we'll say, actually your RDP is down. I can't contact the end service. What that means is message flow stops. Basically, I'm not even going to try and deliver messages. So that's in the case that your downstream system is down. That is, there is no connection. Well, let's say our connection starts again. The connection's up, there's a TCP connection, I can ping the end server. But actually there's something wrong with my end service. So let's say I've called it with bad data. And I'm getting, I know, an error code, a 503 or something like that, instead of the normal 200 OK that I'm expecting. Well, that's slightly different, right? Here what we're saying is, well, actually we've delivered the data to your end service, and we've got some kind of valid HTTP response. So what we'll actually do is we'll increment a counter saying, you've got an error there, you need to do something about it, but actually the connection is fine, so we need to move on and continue processing the messages. Okay, so that's in the messaging world. The idea here is that we've got persistence, we're reading from a queue, and we must ensure that that message gets to the endpoint. If the endpoint throws it away, well, as long as it sent us something to say it's got the message, that's the endpoint's problem, not us. All right. So what about, we've got this feature called a microgateway. Well, how does that work? Well, that's more REST-based. Okay, so what will happen there is we'll get the outgoing message, and then any response that comes back will come back, and that looks like a response message on the messaging broker. So in there, you've got more, instead of a queued, decoupled system, you've got a kind of like a pass-through system. Yeah. And what that's going to do is you can record messages in both directions. So actually, Aaron's got a great code lab that illustrates how you can use the microgateway for that case, and that's really useful for. Actually, I've got a customer. I should name and shame here. It's Oracle Transport Manager has a brilliant habit of you send it a request, you get a 200 OK back with an error code in the 200 OK indicating that Oracle Transport Manager didn't like the data.
Oh, that's bad.
Now that is bad.
Yeah.
So how do you deal with that? Well, what we do is we put a micro gateway in there, and we have a response queue, and we can record in that response queue every single response from Oracle Transport Manager. And so we'll look through the 200 OK responses, looking for a piece of text that says error. I mean, you shouldn't have to do this stuff, but there you go. That's
wacky, man.
Yeah.
Yeah. So yeah, I guess, yeah, it kind of really depends if you're doing messaging or gateway mode. If it's in gateway mode, it's, yeah, because you're doing pass through the publisher, this guy is going to have some kind of timeout associated with him, right? So if your downstream system's offline, eventually your publisher is going to time out, right? But if you're in messaging mode, the publisher sends it to the broker, not to the back end. So it sends it to the broker enqueues it, and then eventually, the RDP will read the message from the queue. Well, eventually, it's decoupled. And if your downstream system is down, the RDP is just going to continually retry until it comes back up. So It'll if it's just down completely, yeah, it'll just retry. You can also specify, Tom, correct me if I'm wrong, but you can specify TTL on the queue here so that, if you had some REST messages that were timely, 30 seconds is too long, then you could actually expire them out of the queue if you wanted to.
Yep, and then you can use all the dead message queue loveliness. That's
right, yeah. So real cool way of mashing up, Solace PubSub and queuing with RESTful applications, right? We can talk REST, we can talk posts, we can do gets with the microgateway. You can mix and match, whether you want to use REST on the consumer or the publisher, or, JMS or MQTT, for example. So lots of different things.
What's really cool about this from an architectural point of view is it gives you a really easy way to integrate with the SaaS offering. And it's a really nice way of bringing HTTP REST stuff into the event-driven world. Because your RDP, as it's posting out, it begins to look like a webhook, right? Something's happened in the event. Yeah. I'm now sending out a webhook, right? That's pretty cool. So all of a sudden, we've turned our event-driven system that's pure kind of streaming protocol based into one that's bringing REST in, and that it kind of moves us into that world of bringing REST into the event-driven world, and a REST event on-ramp and a REST event off-ramp, which is pretty cool.
Yep, and it's actually very easy to configure. So you just say you want a new RDP. So here's my RDP. Then you need to assign it to a queue. Actually, edit. There should be a queue thing here. No, where is the queue?
You have to create a separate. So create your clients.
This has changed. This has changed. There is a queue binding. The queue binding's disappeared. Is it under queues now? No, it can't be.
Just while Aaron's doing that, so you said even if the downstream system is down, there is no message loss. Absolutely. That is completely what we're trying to do here. It's bringing that messaging semantics of guaranteed no message loss to the REST world, which is great, right? Takes a lot of hassle out of that.
I'm going to go figure this out later. But yeah, I think there's supposed to be a queue binding on this screen, and there's not, so that's wacky. I'll check that out. Okay, how are we doing? Oh my gosh, we're actually over. So let's talk much quicker, and let's finish off these last couple of questions here in the next 5 minutes. This has actually been quite busy. Hey, Jonathan, how's it going? Does a broker store a copy for each offline consumer? If you have publish subscribe and you're using queues, and so it's persisting, multiple copies of a message to disk, the broker only stores one copy on the disk. Solace is all passed by reference. So even if you have a 1 to 10 fan out, we don't write 10 copies on the disk. Unlike other broker technologies, that are out there, we only store each copy once. Same with sending it over the network, right? We only send it over the network once, and then it's then fanned out to however many consumers need it. So, yeah, pass by reference, one at a time. Thanks for the question.
That's if you think about it, that's very much like the Kafka architecture, right? Where you write once to the log and you expect the consumers to read from an offset. Difference between Kafka and Solace in that kind of space is, well, with Solace, we keep that offset as a piece of broker state, which makes writing your clients easier.
Yeah. The broker's a lot smarter in the Solace world, and the clients are a lot thinner.
Yep.
Whereas Kafka brokers are literally just a file system. That's what
it's basically an abstracted file system, yeah.
Mm-hmm. All right. Thanks, Jack. Good. We will check that out about Boomi. Yeah. We'll get some Boomi experts on there, and we will check it out. That's a great question. I've run into this since I joined Solace. All right. What can I do? I don't have a local broker running. Okay. So by default, due to legacy reasons from the dawn of time, when you create a message VPN in Solace, the radius authentication is the default. That's just the way it is. And so the very first thing every Solace administrator, every Solace person does when they create a new message VPN is you have to go in there and just turn that off. I mean, with SEMP v2, if you're doing things with SEMP, you should be able to do that programmatically. But if you're using the GUI or using, CLI, you do have to go and change that manually each time you create a new message VPN. So
yeah, it's just in the VPN settings screen. You just go to authorization.
That's right. I think I can actually see it. I just can't do anything about it. So settings, advanced settings. Because this is Solace Cloud here, I don't have full admin rights to the whole broker. So I don't think I have the ability to change.
It doesn't look like it. It's normally the first section.
Yeah. But yeah, when you create a new message VPN, yeah, I don't have access to I should run it with a local, So I have a new laptop now. So the last time Tom and we did this a month ago, I was on my old laptop, which decided to power down about 5 seconds into our live stream. That was fun. Anyway, I'm on a new laptop. It's much beefier and can run lots of things without straining. So I should probably run a Docker container locally so I can show how do you create a VPN. Because in Solace Cloud, that's all kind of taken away from you, right? So anyway, thanks for the question there, Vladimir. But yeah, when you do it, that should be the first thing that you do. Go and turn it off to basic or no authentication if it's on your laptop. And 2, by default, message VPNs are created with 0 message spool. They have 0 bytes storage. So if you're creating a queue and then you're trying to do persistent messaging and nothing's working, it's because your newly created VPN by default has 0 message spool. So that's another thing to check out when you create a new VPN. Yes, he answered that. Yes.
Yeah.
All right. What's the correct form?
We just did that. Yeah.
Oh, I'm backwards. I'm going backwards. Okay.
No, you're going forwards. It's just Bob. Said it twice.
All right, and Manish. All right, and that's the end of the question. So, all right, thanks, Manish. Tom, we're actually over by about 8 minutes, so I think that's probably a good spot to end up. I'm going to just switch this to join the Solace community. Yeah, and put on. Let's see. Here we go. Here's a scroller. So thanks all the people out there for attending. Thanks for all the good questions. I really enjoyed the kind of range of questions this time, from some of the more introductory stuff to more use casey and kind of complementary questions. Thanks, Tom, for joining. As always, it's been great. I'm going to go get some dinner. I think it's 8 o'clock here. I'm a little bit hungry. Thanks to everybody. Stay tuned. Solace.com/events lists all of the upcoming Solace events that we have planned. I'm sure we'll be doing another one of these office hours at some point in the future. So from Aaron and Tom, thanks for joining us, and see you next time.
See ya. Bye.